with AS Chemistry 2.3 green chemistry, there's so many things you can talk about with this. You have got reams and reams of notes, and there's all sorts of stuff that you can find on the internet in terms of the green chemistry topic. I'm just going to run through kind of like the key important bits. With the green chemistry, it's going to come up attached to another concept, okay? So it's going to come up at the end of like a increase in temperature rates question, or it's going to come up at the end of making an alcohol, okay? So it's always just going to be added on. Very unlikely that'll be a question on its own, because green chemistry is talking about all the different impacts that it has. So two different ways that we can look at green chemistry. The first one is looking at chemical synthesis, okay? So chemical reactions to make a new product, carbon is often given off as a byproduct, okay? So we're looking at making new products, whether that be making ibuprofen or making plastics, okay? We're making a new product, and often carbon is given off as a byproduct. It's not something we want, but it's just given off. So what we want to look at then is kind of like the impact. So environmental impact. A lot of chemical reactions can be produced by byproducts that are harmful to the environment, therefore need to be monitored or measures taken to reduce the production and effect of these products. Major environmental impacts are concerned with the combustion of carbon containing compounds as they release CO2. We then know that if too much CO2 gets into the atmosphere, it gets stuck in the ozone layer. Okay, so the ozone layer, it'd be stuck up here. When the sun's rays shine through, most of the sun's rays get reflected back out. However, if you've got loads of CO2 building up at the top of your ozone layer in your atmosphere, it'll trap the sun's rays and it'll cause the Earth's temperature to heat up. Okay, so you can obviously think about trying to capture the carbon before you release it, thinking of ways to use energy that isn't to use carbon, loads of different ways. So, social impact. Pharmaceuticals are an example of how chemistry can impact scientists socially. Aspirin is an example of a drug, a form of carboxylic acid containing a benzene ring, which we'll do at A level, produced from citric acid and ethanoic anhydrate. Today is widely used as a painkiller, which provides society with many social benefits and pharmaceutical companies with economic ones. Okay, so that's looking at a good thing about chemical synthesis. Okay, polymers is another one, looking at how we've made nylon and polyester. Okay, again, really good consumer products, knife-proof vests, clothing and various products. Okay, we're then looking at how we can break down these plastics by water, so looking at, again, our environmental impact. Another thing we need to think about then, economic impact. Obviously, supply and demand is huge. Okay, demand for such chemical products means they have economic value, which can lead to employment. Okay, it's also important for manufacturers to consider percentage yield. So percentage yield is how much you actually make over the theoretical cost. That's a year 10 equation, but you've got to be thinking about that. Are you making enough? It's desirable to have high atom economy, so that means for every atom that goes in, you make the same atoms out. Little or no waste product, only the desired product. Okay, reactions that have byproducts can be collected and reused. That's something that we're working on, so it significantly reduces the waste. So they're kind of things that you need to be thinking about, well, as you undergo chemical synthesis. So the other thing that kind of relates to green chemistry is energy production. So using fossil fuels to create energy. So burning a fossil fuel normally to spin the turbine so that energy is created. A little bit of an example here of combustion. Two types of combustion, complete and incomplete. Carbon compounds burn. They react with oxygen in the air to produce CO2 and H2O. If there's insufficient oxygen, that will produce carbon monoxide. Toxic gases, sometimes nitrous oxide. So you have to be careful when we're burning fossil fuels. Have you got enough oxygen? What are you going to do with the CO2 after you've made it? Really careful if we accidentally produce CO, so carbon monoxide, gets taken in by your body instead of oxygen. Catalytic converters are one way that we're looking at limiting this. So they're attached to exhaust systems. So obviously your car or van or bus or whatever you're using to travel will use combustion because it's burning petrol normally or diesel to create energy. So what we fit are these little converters that they contain a catalyst, and they use heat from the energy to convert the nitrous oxide into nitrogen and the carbon monoxide into carbon dioxide. So these are less harmful to the environment. Still a big problem because carbon dioxide is still being released, but carbon monoxide is obviously more harmful to us. Another big thing comes with burning fossil fuels, acid rain. Okay, awful lot of sulfur impurities are released when we burn fossil fuels. That can go up into the atmosphere, into the water, into the clouds, produce sulfur dioxide, creating weak sulfuric acid. Okay, this falls on the earth as rain. Okay, and that has major impacts on ecosystems, obviously limestone structures, but also ponds, lakes. Okay, to combat this issue, calcium oxide and gypsum can be used in factories to remove these sulfur impurities. Pollutant weights are reacted with these substances to help minimize the harmful gases in the atmosphere. So we use these two products here so that they don't release the sulfur impurities, so it doesn't go up into the clouds. And then finally, something that a lot of people are looking at is making things carbon neutral. Okay, so carbon neutral, kind of like the word suggests, means that the amount of carbon produced in a chemical reaction is cancelled out by a counter process, so there is no net increase of concentration of CO2 in the atmosphere. A big example of this is biofuels made from crops, which are carbon neutral because they're plants. They take in carbon dioxide for us through photosynthesis, but that's given out in combustion. Okay, so so all the carbon dioxide is technically that plant's taken in. So even when we burn it to combust, technically it's taken in a load of CO2 in its lifetime, so it should even it out. Okay, but using biofuels is a really lengthy process and only small amounts are produced. So there's a lot of talk of, is it actually carbon neutral, because the amount of energy that it releases and requires to burn, is it actually going to take in enough during photosynthesis during its lifetime? Okay, like I said, these questions, there's so much that you can do with this, but I've just picked out some quite important bits to it. Again, if you've got any questions, just come see me, email me.